There are a lot of factors that affect airport capacity. We will go through several of them to lay the groundwork for our next series of videos on calculating airport capacity and delay. First, let's talk about the number of runways and runway layout. Now, the FAA estimates that one runway can accommodate approximately 200,000 airport operations per year. That's a starting point for us. More runways are good for capacity, but there are caveats. Additional runways cost lots of money, so they have to be well thought out before they are built. An additional runway only adds to capacity if both runways can be used simultaneously. Runway layout, configuration, and distance between parallel runways all determine whether or not they can be operated simultaneously or not. So let's dig into that just a little bit more. A single runway has a capacity of about 100 small aircraft or 60 larger aircraft per hour during good weather. During poor weather or instrument conditions, capacity drops to about half of that, 40 to 50 hourly operations. Two parallel runways do not necessarily double the capacity of one runway. Close parallel runways are those that are less than 2,500 feet between runway center lines. If there are at least 700 feet between runway center lines, they will allow for simultaneous visual operations only. Close parallel runways are considered a single runway for instrument weather conditions. Next, we have intermediate parallel runways. Those have minimum of 2,500 feet between runway center line. They go up to 4,300 feet separation. They can be used simultaneously for visual operations, but require close coordination, which results in higher air traffic control workload during instrument operations. Finally, far parallel runways. These have a minimum of 4,300 feet between center lines, and far parallel runways allow for simultaneous operations in both visual and instrument conditions. So in addition to parallel runways, single and parallel runway layouts, we have V runway configurations that look like this. In the V configuration, the runway that's aligned with the wind at any given time is called the primary runway, and the other runway is called the crosswind runway. During low wind conditions, both runways can be used, and depending upon the weather conditions, V-type runway layouts can be operated in several different configurations. For example, a converging operation. Converging V configuration is when the aircraft operate inwardly toward the V. Converging V configuration can handle simultaneous landings, but not simultaneous takeoffs. By contrast, diverging V configuration is when aircraft operate outwardly, away from the V. Diverging V configuration can handle simultaneous takeoffs, but as you can see, not simultaneous landings. In a hub airport with a V layout, if winds are light, the airport would want to operate the converging V configuration during the arrival bank while operating the diverging V configuration during the departure bank. Finally, of runway layouts, we have intersecting runways. Airports choose intersecting runways when there are relatively strong prevailing winds from more than one direction throughout the year. As with the V layout, the primary runway in the intersecting runway layout, the primary runway at any given time is that which is aligned with the wind, and the other runway is that which is not aligned with the wind is called the crosswind runway. Simultaneous operations are possible with intersecting runways, but they must be highly coordinated with air traffic control. In the next video, we will talk about some of the other factors affecting airport capacity.